Okay, 8.3 talks about geometric sequences. That starts on page 356. Let's throw a little light on the subject. There we go. Make that a little bit brighter. So, page 356 talks about geometric sequences. Geometric sequences happen all the time in the social and natural world. Let me give you a quick example. Here is a unit. It is 1. I'll write down 1. In fact, I'm going to put this in a little sequence here. I cut it in half. In other words, I alter it by a given ratio. Now I have 2. I alter it by the same ratio again, and now I have 4. I alter it by the same ratio once again, and now I have 8. I alter it by the same ratio yet again, and I have 16. One more time, and now I have 32. You can count them if you want. And again, and now I have 64. And I could go on and on like this. This is different than our arithmetic sequences because in here the difference is 1. Here the difference is 2. Here the difference is 4. Here the difference is 8, and so on and so forth. So there is no common D. There's no common difference. It changes all the time. However, there is one thing that's the same. There is a common ratio. And that is the key to a geometric sequence, and we call it R, the common ratio. The ratio between one term and the next term is always the same. So the next term is always double the last term in this particular ratio. So R would equal 2. So let's put that in the back of our mind. Let's put that in on our toolkit, our mental toolkit anyway. There's a common ratio between the terms. So these two terms, the ratio between them will be same as these two terms or any other sequential terms. So let's take let's see if we can figure out the formula then that will allow us to calculate the nth term. That seems to be the first thing we want to do. Here we had our formulas, and we had our arithmetic formulas. We had the nth term formula that looked like that, and we had a sum formula. We had two different sum formulas actually, depending on whether you knew what L was. And we need some geometric formulas too, so we can calculate the nth term of a geometric series or sequence. And we also need to know whether we can we need to be able to recognize geometric sequences too. So let's derive that formula. Let's take this sequence here. We start with 100, 400, 1600, 6400, 25,600. We'll stop there. And as you can tell right here, that's the easiest place to tell, we're multiplying by 4 each time. So the common ratio here is 4, or R equals 4. So we went times 4 here. And then let's see if we can phrase this all in terms of A1. And the reason for that is we often know what A1 is, and we want to find out what A16 is. Well, if we know what A1 is, and if we can figure out what R is, maybe we can calculate A16. So this was A1 times 4 gave us A2. A1 times 4 gives us A3. A1 times 4 times 4 times 4 gives us A4. This is A1, A2, A3, A4, and A5. And we have to multiply A1 times 4 times 4 times 4 times 4. And that means it times 4 and then times 4 and then times 4 and then times 4. That's what that's all about in order to get A5. So notice this. Multiplied by 4 is multiplied by R. Multiplied by 4 times 4 is multiplied by R squared. In other words, times R squared. Multiplied by this stuff is times R to the 3rd power, and this is times R to the 4th power. Now if we look for a pattern here, let me write this down here. A2 equals A1 times R to the first power. That's what r is. A3, that's this one here, equals A1 times r squared. 4 times 4, 16. 16 times 100, 1600. A4 equals A1 times r cubed, 4 times 4 times 4. And A5 equals A1 times r to the fourth. So you can see in each of these cases, whatever the number of the term was, we can do this formula here. So we have A1 and we have r raised to a power that's 1 less than the term. So the mathematicians would write that out like this. They would say that A of n equals A1 times r to the n minus 1. And there's nothing worse than getting up in the morning and seeing an exponent expressed this way, n minus 1. I know it's complicated, but here it's just 1 less than you saw down there for n. So in this particular sequence, if I wanted to know what the 16th term was, I know that it would be A16 would equal 100 times 4 to the 16th power. Now that's a large number, I don't know what it is, but that would be relatively easy to figure out on a calculator. Whoops, did I say 16? I meant 15, it's got to be n minus 1. So r to the 15th power. So that's what a geometric sequence is, and that allows us to do some exercises in the next video.